All right, let's set a scene. Imagine you're on a server, and you just get that feeling. Something's not quite right. You've got this one nagging question, and you know the clues are probably hiding in plain sight. And that is the question that kicks off our entire investigation. It's not really about blame. It's about figuring out what actually happened. See, the command line remembers everything, and sometimes it remembers just a little too much. So today, we're going to learn how to read those memories.
And this brings us to a really crucial point. We need a professional workflow for this. This isn't about just poking around, hoping to get lucky. It's about having a disciplined process, one that holds up when you're tired, you're busy, and you absolutely have to be right. This is our guiding principle.
So, our investigation begins at what I like to call the digital crime scene, the shell history file. This is the log of every command, every shortcut, and yeah, every mistake. It is absolutely the highest signal place to start looking for accidentally exposed credentials.
Okay, here's where we need to shift our thinking a little bit. We're not just searching for the word password. Honestly, that's a rookie mistake. What we're really hunting for are human shortcuts. You know, those little tricks and copy-paste people use when they're in a hurry, a build is failing and they just need to get it working. That's where the secrets hide.
And here's what those shortcuts usually look like in the wild. We're talking about API keys typed right into the terminal, or those super long curl commands pasted from a tutorial with the authorization headers still in them. Or even, and I've seen this, entire private keys or config blobs just dumped onto the command line.
Okay, so that brings us to our first real phase, triage. This is all about the rapid search for evidence. We're not trying to boil the ocean here and search everywhere at once. We're going straight to the most likely places to find clues, and we're doing it fast.
These are your go-to spots, your primary evidence lockers. You're going to start with the current user's history, then check root's history. But don't forget the ones that people often miss, ZSH history files, which are a little different, and critically, the home directories of service accounts. You know, the ones used for deployments or scheduled cron jobs.
And you know, when you're digging through these files, don't expect some kind of complex, sophisticated attack. Most credential leaks aren't dramatic at all. They're kind of boring, actually. They usually look a lot like what we've got on this next slide.
See? It's that simple. Just a plain old database connection string. Someone was just trying to get something done quickly, they threw the password right there on the command line, and now it's saved in the history file, maybe for months.
And that's the human element, right? This usually isn't malice. It's just one exhausted person at 2 in the morning copying and pasting a command to fix a problem. The command works, the ticket gets closed, everyone moves on, but that history file? It becomes a perfect little time capsule of that one risky shortcut.
Now, it's important to know that not all evidence is created equal. A bash history file is pretty simple. It usually just logs the commands. But Zshack? Oh, Zshack can be a gold mine. As you can see here, Zshack can be set up to include timestamps and other metadata, which is an absolute game changer when you're trying to reconstruct a timeline. It can also write history incrementally, meaning you might see a mistake almost as soon as it happens.
Okay, so maybe you've found something, or maybe you've found nothing. Either way, this next step is absolutely critical: verification. Before you jump to any conclusions, you have to analyze the context of your evidence, or, the lack of it.
So you check a user's home directory, and the .bash history file is just empty. Your first thought might be, great, it's clean. Or maybe even worse, oh no, someone wiped it. But hold on. An empty file can mean a lot of different things.
Look, the key here is not to guess, it's to verify. As this slide shows, an empty file could just mean the user has good hygiene and limits their history size. Or maybe it's disabled in their shell config. It could even be redirected to dev null just to be thrown away. Sure, wiping is a possibility, but you have to rule out these configuration issues first.
And this brings us to the moment your entire job changes. You've been investigating, digging around, and then you find it. A live, active credential. What do you do now? Well, we immediately shift from investigation to containment. I really cannot stress this enough. Your goal is no longer about finding cool stuff. It is about containing the problem and reducing harm. And that means you absolutely, under no circumstances, test the secret to see if it works. That is the single biggest and most dangerous mistake you can make.
Instead, you follow a very clear protocol. This slide lays out the sequence. First, you document your finding, but be really careful not to copy that secret all over the place. Second, you use the proper system, your cloud provider, your password manager, whatever it is, to rotate the credential. Third, you invalidate any active sessions. And finally,
You go hunting to see if that same secret was reused anywhere else.
But sometimes you're in a tough spot, and you have to make a judgment call. Do you rotate the secret right now, or do you investigate just a little bit more first? This slide gives us a framework for that decision. If the secret gives broad access or it could be exposed externally, you rotate it, now. But if rotating it is going to break a critical system and you have strong monitoring in place, you might carefully investigate first to understand the full blast radius.
Okay, so the fire's out, the immediate crisis is over, but the work isn't done yet. The final phase of our process is hardening. How do we make sure this doesn't happen all over again?
And this is such an important point. Hardening isn't about punishing people for making mistakes. It's about system design. It's about making the secure way of doing things the easiest and most convenient way, so people don't even feel the need to take those risky shortcuts in the first place. So, what are some practical things you can actually do? Well, you can configure your shell to automatically ignore commands that tend to contain secrets. Even better, you can push for workflows that use environment variables or a secrets manager instead of pasting things. And definitely be aware of those fancy .files setups that might be changing history behavior behind your back.
So let's just put it all together. Here is the entire workflow in 5 clear, simple steps. 1. Locate all the history files. 2. Triage them for high-risk patterns. 3. Prove how the shell is actually configured before you draw any conclusions. 4. Contain any secrets you find. And finally, 5. Harden the system to prevent it from happening again. It's a clean, repeatable loop.
And that really brings us to the final thought here. Your command line isn't just a tool, it's a living record of your habits. The thing that leaks credentials usually isn't malice, it's momentum. It's the habits that we all fall into when we're under pressure. So the real question to leave with is this: are your habits safe?